Hi, this is Jordan, and I just previously worked on the vinegar and baking soda rocket project, and it really only required an empty water bottle, baking soda, and distilled white vinegar, which I used. This is the baking soda that I used, and this is the distilled white vinegar that I used. And here are the remnants of everything that was used. It's just vinegar with some evaporated baking soda inside of the bottle. So moving on to the science aspect of the experiment, I would like to talk about why the bottle shot out like a rocket when it was mixed together and the cap was bottled and everything. So when the baking soda and vinegar are mixed together, the reaction produces water and carbon dioxide gas, and in the capped film bottle, the carbon dioxide gas builds up until the pressure of all the contained gas causes the bottle to pop open. Pressurized carbon dioxide then quickly escapes from the bottle through the open bottom. This is how the chemical reaction provides to thrust the bottle as it needs to in order to launch. You may have noticed that when the least amount of vinegar was used, it took a little longer to launch than when more vinegar was used, for those of you who've done this experiment before. And this would be because there was less vinegar in the bottle, so there was more space for the carbon dioxide gas to fill. It takes longer for more carbon dioxide gas to be made from the reaction, and therefore is needed to fill this larger space and build up enough pressure to pop off the lid. Overall, when the least amount of vinegar was used, more carbon dioxide can fill the bottle, and a higher launch height would be seen. So I'd like to talk more about the scientific process, and in deeper analysis, baking soda and vinegar react with each other because it's an acid-base reaction, and baking soda is a bicarbonate, and vinegar is an acetic acid. One of the products this creates is again mentioning carbon dioxide, so that's one of the products that those two create. The baking soda and vinegar react with each other because they exchange atoms, and in this case they're exchanging a proton, which is a subatomic particle that makes atoms. You can also think of a proton as a hydrogen atom that is missing an electron. And this reaction, baking soda acts as a base and takes a proton from vinegar, which is an acid. The reaction releases gas because when the baking soda receives the proton, it transforms into water and carbon dioxide. Baking soda is sodium bicarbonate. Each molecule of baking soda contains a sodium atom, an hydrogen atom, an oxygen atom, and a carbon dioxide molecule. Vinegar contains acetic acid, each molecule of which contains a hydrogen atom and an acetate ion. When combined, the hydrogen in the acetic acid meets up with the hydrogen and the oxygen atoms in the baking soda to form a molecule of water, while the acetate ion grabs onto the sodium atom and forms a salt, sodium acetate. The carbon dioxide molecule, free of its other chemical bonds, can now escape and bubbles forth as a gas. An ion is a charged atom or molecule, just for the sake of mentioning exactly what an ion is, for those who don't know. And acetic acid doesn't break apart on its own in water as much as sodium bicarbonate. It's mostly diluted, so it's not as strong. But when we mix the baking soda and acetic acid, in water together, the acetic acid gives its proton to the breaking apart baking soda, and together form sodium acetate, water, and carbon dioxide as products. And these products are created very quickly, and the carbon dioxide comes out as a gas. And by reacting with each other, the acetic acid, and which is acidic, of course, and the basic sodium bicarbonate give up a lot of their energy and end up creating products that have lower energy relative to one another.